All right, strap in everyone, because today we are going deep on image feature extraction.
Ooh, exciting.
Yeah, I'm pretty pumped for this one. You
Yeah.
sent me a ton of research papers and articles on this, and
Hopefully not too many.
no, it was great, but I've got to say I'm looking at my phone's facial recognition in a whole new light now.
Yeah, it's pretty amazing what's going on behind the scenes.
It's not magic, right? This is some serious science going on.
It really is. Really is.
So, to kick things off,
Yeah.
what exactly IS image feature extraction? I mean, like, help us understand how computers actually see and interpret images.
Okay, so imagine this. You're trying to describe a friend's face to someone who's never seen them before, right?
Okay, yeah.
You wouldn't just list every single detail, like the exact shade of their skin or the width of their nose.
You'd probably focus on, like, their crazy eyebrows or something.
Exactly. You'd pick out the most distinctive features, the things that make them unique.
Yeah.
And that's essentially what image feature extraction is all about.
So we're teaching computers to find those defining features, like the computer equivalent of piercing blue eyes or a mischievous grin.
Exactly. It's about identifying and representing those distinctive structures within an image.
Okay, so it's more than just a computer going, hey, look, a cat.
Way more. It's about finding those unique characteristics, those telltale signs that distinguish one image from another.
Okay, so instead of describing every single detail of a cat, we're teaching the computer to focus on the essential catness.
You got it. And that's where it gets really interesting.
Made on me.
Because once a computer can reliably identify those features,
Yeah.
it opens up a whole world of possibilities.
Okay, so now my brain is starting to melt a little bit.
Oh.
So we're not just talking about, like, tagging photos on social media, right?
No, not even close.
Okay, good.
Think self-driving cars navigating busy streets.
Okay.
Doctors using AI to spot tiny tumors in medical scans.
Whoa.
Or even archaeologists using image analysis to uncover hidden details in ancient artifacts.
Wait, hold on. I need to process this for a second.
Sure.
We're talking about computers that can, for example, help a doctor see something in an X-ray that, like, a human might have missed.
Precisely. By analyzing the extracted features, computers can often detect subtle patterns and anomalies that might be invisible to us.
Wow, that's pretty incredible.
It is.
All right, so how do we teach computers to do this? Is there like a computer vision 101 course where they learn to spot the difference between, I don't know, a cat and a dog?
Well, it's not quite that simple,
Okay.
but there are a variety of techniques that we use to extract these features.
Okay.
And some of them are actually pretty intuitive, like edge detection.
Edge detection, so like finding the outlines of objects.
You got it. Think of it as the computer sketching the outlines of the world.
Oh,
It's identifying those boundaries, the lines that separate different objects or regions within an image.
so like if a computer's looking at a picture of a busy street, edge detection would help it separate the cars from the buildings from the pedestrians. Yeah.
And there are some clever algorithms like the Sobel operator or the canny edge detector that help us do this really effectively.
The canny edge detector.
Yeah, and in fact, the canny edge detector is often used in medical imaging to isolate organs or tissues,
Oh, wow.
which can be incredibly helpful for diagnosis.
That makes sense. What about, so we've got the edges, but what about those corners where those edges meet?
Oh, absolutely.
Those play a role too.
Those corners, yeah, those are crucial.
Okay.
Identifying those corners is another key technique
Uh-huh.
called, you guessed it, corner detection.
The corner detection.
Okay, these points where edges intersect, they're like landmarks in an image.
I like that analogy, yeah.
They're stable features that help define the shapes of objects.
So like if we go back to our cat example, the corners of its ears or the points where its whiskers meet its face would be important features?
Exactly.
Okay.
And the Harris corner detector is a popular algorithm for this.
Harris corner detector.
And it's actually used in a lot of real-world applications like 3D modeling and object tracking. Imagine a robot trying to grasp an object. It needs to know exactly where those stable points are to pick it up correctly.
That's fascinating.
Yeah.
So we've got edge detection to find the outlines and corner detection to pinpoint those key landmarks. What other tricks do we have up our sleeve to teach computers to see?
Well, shapes are important, but so is texture. Think about the difference between a smooth, shiny apple and a rough, bumpy orange. We need a way to teach computers to feel those differences.
Okay, I'm intrigued. How do we give computers a sense of touch?
Well, that's where Gabor filters come in.
Gabor filters, okay.
Yeah, they're like tiny little fingers running across an image, sensing those subtle variations in texture.
We're like,
That is them, detecting the ridges in a fingerprint or the grain of wood in a piece of furniture.
So they're analyzing the patterns that go beyond just the outlines and the shapes.
Exactly. And it's incredibly useful in fields like material science and even art analysis.
Hmm.
Imagine a computer being able to distinguish between a genuine Van Gogh painting and a forgery based on the subtle texture of the brushstrokes.
Whoa, that's wild. So we've covered edges, corners, and textures. Are there any other fundamental features that computers need to learn about?
Those are some of the basic building blocks, but, as you can imagine, the real world is a lot more complex.
Oh yeah, for sure.
Objects can be at different angles, distances, even partially hidden.
Right. Like if that cat we keep talking about decided to, take a nap behind the couch, it's still a cat, but it might look very different to a computer.
Exactly. That's where more advanced techniques come in, like
Ooh,
SIFT,
yes.
scale invariant, feature transform.
Okay, what is that?
So think of it as giving the computer the ability to recognize its owner's face, even if they're wearing sunglasses and a hat.
Okay, yeah. So it can see through those superficial changes and focus on the underlying features that really matter.
Precisely. SIFT is great at identifying those key points that remain consistent even when an object is rotated, scaled, or viewed from different angles. It's a real game changer for things like object tracking and 3D reconstruction.
I see, I see. I'm starting to see how all these techniques kind of build on each other.
Yeah.
We start with those basic features like the edges and corners, then we layer on these more sophisticated methods to deal with the complexities of the real world.
Exactly, and it doesn't stop there.
Oh, there's more.
Yeah, there's another powerful technique called ICF, or integral channel features.
Considerable channel features.
This one's a bit more technical,
Mm,
but essentially it's about analyzing the distribution of gradients.
gradients.
Yeah, or changes in intensity across an image, and it's particularly good at detecting objects in cluttered backgrounds,
Okay.
which is why it's often used in pedestrian detection systems for self-driving cars, for example.
Oh, wow. So it's like giving the car a superpower to pick out those pedestrians even in a crowded street scene.
You got it. And these are just a few examples. There are tons of other fascinating techniques out there, each with its own strengths and weaknesses.
It's incredible to think how far we've come in teaching computers to see.
It is.
But you mentioned earlier that this is still a rapidly developing field, right?
Oh, yeah, absolutely.
So what's on the horizon? What are the cutting edge advancements that have you really excited?
Well, you can't talk about image feature extraction without mentioning deep learning,
Deep learning, okay.
particularly convolutional neural
It's
networks,
CNNs.
or CNNs, yeah.
I've heard that term thrown around a lot.
Yeah,
But to be honest, it all sounds a bit like science fiction to me.
I get it. It's a whole other level of complexity. But the basic idea is that CNNs learn to extract features directly from the raw image data.
Okay.
Instead of us having to, hand design those features,
Yeah.
the CNN figures it out on its own through a process of training on massive data sets.
So we just give the computer a huge pile of images and say, go figure it out, buddy.
Pretty much. And the results are mind-blowing. CNNs are achieving superhuman performance in tasks like object recognition and image classification. They're really the driving force behind a lot of the AI we see in the world today, from facial recognition systems to medical image analysis tools.
Okay, so that's pretty amazing. But I have to ask, if CNNs are so good at figuring things out on their own, do we even need all those other techniques that we talked about?
That's a great question.
Are edges and corners becoming obsolete?
That's a great question. And the answer is not quite.
Okay.
Those traditional techniques still play a vital role, especially when dealing with limited data or computational resources.
That makes sense.
They're also often used in conjunction with deep learning methods to enhance performance.
So it's not a case of one replacing the other. It's more about finding the right tool for the job.
Exactly, and that's what makes this field so dynamic and exciting. There's always room for innovation and new approaches.
I like that.
Yeah.
All right, so we've covered the how of image feature extraction, the techniques and algorithms that make it all possible.
Right.
But now I'm really curious about the why.
Okay.
What's the big picture here? What are the real-world applications that are making a difference in people's lives?
Well, you mentioned earlier the example of doctors using AI to spot tumors in medical scans.
Yeah. Yeah.
That's a perfect example of how image feature extraction is being used to improve healthcare.
Yeah, that one really stuck with me. Are there other examples in medicine?
Oh, absolutely.
Okay.
Image feature extraction is being used to analyze everything from X-rays and CT scans to microscopic images of cells and tissues.
Wow.
It's helping doctors diagnose diseases earlier, personalized treatment plans, and even develop new drugs and therapies.
That's incredible. And what about other fields? I know you mentioned self-driving cars earlier.
Yeah.
How's image feature extraction playing a role in transportation?
Oh, it's absolutely essential.
Yeah.
Self-driving cars rely on a complex network of sensors and algorithms to perceive their surroundings and make decisions in real time. Image feature extraction allows them to identify and track objects like other vehicles, pedestrians, traffic signs, and lane markings.
It's mind-blowing to think about all the calculations happening behind the scenes every second to keep those cars on the road.
It really is, and it's not just cars.
Oh.
Image feature extraction is also being used in drones, robots, and even satellites to automate tasks, improve navigation, and gather valuable data.
So we're talking about a technology that's not just changing how we see the world, but also how we interact with it and move through it.
Precisely.
Yeah.
And it extends far beyond transportation.
Yeah.
Image feature extraction is being used in everything from security and surveillance to retail and entertainment.
Okay. Yeah.
Think about facial recognition systems used for security checks at airports or personalized shopping recommendations based on your browsing history.
Okay, I'm officially mind blown. This technology is everywhere. But before we go too far down the rabbit hole, I want to circle back to something you said earlier about CNNs and their ability to learn from massive data sets.
Yeah.
That raises some interesting questions, right? Like, where are all these images coming from that these algorithms are being trained on? And are we sure they're representative of, the diversity of the real world?
That's a really, really important point.
Yeah.
The data sets used to train these algorithms can have a huge impact on their performance and potential biases.
Right.
If a data set is primarily composed of images of, say, light-skinned individuals,
Yeah.
the algorithm might not perform as well when trying to recognize people with darker skin tones.
Yeah, that's a sobering thought. So it's not just about the technology itself, it's about the data that we feed into it.
Exactly, and that's why it's so crucial to have diverse and representative data sets that reflect the complexity of the real world.
Right.
Researchers are working hard on this, but it's an ongoing challenge for sure.
It makes you realize that even though we're talking about, computers and algorithms, there's still a very human element to all of this.
Absolutely, and that human element extends to the applications of this technology as well. We've talked about some of the amazing things image feature extraction can do, but it's important to remember that it's a tool.
Uh-huh.
And like any tool, it can be used for good or for ill.
So there are potential downsides we need to be aware of.
Of course. Take facial recognition, for example.
Yeah.
It has the potential to enhance security and make our lives more convenient, but it also raises serious concerns about privacy and surveillance.
It's a bit of a double-edged sword, isn't it? So what steps can we take to ensure that this technology is used responsibly?
Well, for starters, we need to be having open and honest conversations about the potential implications, both positive and negative.
Okay, yeah.
We also need to develop clear guidelines and regulations around the development and deployment of these technologies.
So it's not just about the scientists and the engineers, it's about policymakers, ethicists, and really all of us as a society.
Exactly. This is a conversation that needs to involve everyone.
Wow. Well, you've certainly given me, and I'm sure our listeners, a lot to think about today. It's incredible to see how far we've come in teaching computers to see, but it's also clear that there's a lot more work to be done to ensure that this technology is used ethically and for the benefit of all.
Couldn't agree more. Yeah, it's a fascinating field with immense potential, but we need to proceed thoughtfully and responsibly.
Well said. And on that note, I think we've reached the end of our deep dive into image feature extraction. I have to say, this has been one of the most eye-opening episodes yet.
Oh, good.
It's amazing to think about all the ways this technology is shaping our world, often without us even realizing it.
Absolutely.
A big thank you to our expert for, taking us on this incredible journey today.
It's my pleasure.
And to our amazing listeners, keep those brains buzzing, and we'll catch you on the next deep dive.